when thinking about what to present, I wanted to share with you some of the history like Hans did, and you will find some common threads, but also a lot about the philosophy behind Materialise. The management philosophy of Materialise is, I would dare to say, nearly 100% inspired by a book. The book, Built to Last, written by James Collins and Jerry Porras. And that book, I think many of you probably know it because you can find it at most airports, simply in the bookstore. It's for many years a very popular book. But I had been reading many management books before that book, and that book really hit me. It was based on scientific approaches. As far as you can be scientific in economics, it's not like physics, but it was a very thoroughly made work based on 3 years of research with a large group of people, led by those two professors from Stanford, based also on a lot of experience of those guys. And what they did is they investigated companies that were considered visionary companies over a long period of time by a lot of their peers. They did large inquiries among leaders of worldwide present companies, and they investigated what the management of those companies considered as visionary companies, who they were in their sector, and how they could have become such visionary companies. So the first thing they did was to look among different sectors what are, by their peers, considered the visionary companies. As they wanted they also wanted some proof that some of the products released by those companies were really changing the world, not just the impression from their peers. And they wanted to look at companies that sustained being visionary, not just a one-time hit, but really through years of continuous innovations, through years of sustained visionary approach. And they also wanted to know that it was not the leader of that company, but that it was the company itself that was a visionary entity. Yeah? So they wanted to study only companies that had been in place from before 1934 in order to be able to look through some serious history. And then finally, they came up with that list, and they chose comparison companies. So you can see this list is a page I copied from the book. I still have a very old copy, as you can see. And on the left-hand side, you find 3M, American Express, Boeing, Citicorp, Ford. And then on the right-hand side, you find companies that originated in the same time frame, around the same type of technology, about the same evolutionary aspect of technology, and that had done at least as well during the first 20 years of their existence as the visionary companies. And then they calculated a stock market index, and the book was published in 1990, and from 1926 to 1990 they investigated if you would have invested $1 in 1926 in a stock market index of the visionary companies, you would have earned $6,326 by 1990. Yeah? And by the way, the story goes on, because all those companies which were considered visionary companies exist nearly 25 years later today still as independent companies. Yeah? The book has been criticized, but fundamentally those companies are still visionary companies. If you would have invested that $1 in the reference companies, you would have earned $935, which is still more than twice what you would have gained by investing in a tracker of the Dow Jones Industrial Index. Yeah? So it's quite remarkable that those visionary companies are not appreciated only by the leaders of their industries, but they are also appreciated by the stock market. And now in the short term, the stock market may do very stupid things, as we all know, but in the long term, all economists say the stock market is always right. So over a period of 70 years, the stock market can be considered right. Why have those companies created more value than other companies according to the stock market? Now, actually, we started in 1990, exactly the year that the book was published. And to be honest, it's only in the year 2000 that I found that book, that I read it, 10 years later. But it was so much coinciding with the way we had already started Materialise, and I found so many elements that I could go chapter by chapter through the book and apply it to Materialise. And that is still what we are doing today on a daily basis at Materialise. Yeah? And from time to time, in the beginning of the year, we evaluate ourselves, how well are we following the book and what can we do better. That's truly how the top management of Materialise is still working today, 15 years later, after we started with that book. Yeah? And one of the things I'm extremely proud about, personally, is that a common thread in all the visionary companies is that they have a core identity. A core identity that consists of a value statement and a mission statement. And this mission statement you see here, which is the mission statement of Materialise, that we want to contribute to a better and healthier world with those words, through, and these were different words when I first pronounced it at the opening reception of Materialise. It was then called, through our hard and software knowledge of stereolithography. That was 1990. That we wanted to focus on the applications of stereolithography for industrial and medical applications. All of this is still very much the core mission of Materialise today. Our value statement was pronounced 2 years later for the first time when we moved through our facilities out of the university, and we ended in an incubation center. So that was when our core identity was already fully established. And that's one of the key elements of visionary companies. I think many of you will have once visited a Johnson & Johnson facility. You always have the Johnson & Johnson credo at the entrance of any Johnson & Johnson facility. And that's a first step that is important to create a visionary company. Now, we have always taken a particular position in the 3D printing industry. I've always been in the opinion that a lot of energy is spent by many companies and research institutes on the creation of those printers, the 3D printers, and relatively little on given attention on how they have to be used for real applications. And today we are confronted with the situation that you have a couple of very large, very important companies like AOS, 3D Systems, Stratasys, many of those stock listed, and it seems as if that is the 3D printing industry. But the reality today is much wider. These are a lot of other machines from different manufacturers that enter the market. And last week, or in the meantime 2 weeks ago, I was in China at Asia Mold, and I simply took some pictures with my iPhone of just all the little machines from different manufacturers that were there. Yeah? And there were 35 machine manufacturers and 6 material manufacturers just present at the Asia mold, and for sure our China office know there are many more machine manufacturers in China than those 35 that were at Asia mold. Yeah? Now when you look then at the applications of those machines, and these are then in this situation mostly the low-end machines, I found this. Yeah? This was the biggest display of products manufactured on those machines. Yeah? If you then look at what are gimmicks or gadgets, yeah, and what are somewhat reasonable products that you could give some functionality, you end up approximately with this. Yeah? These are lamps like Materialise did at the end of the 90s, launching the collaboration with designers, the MGX line of lighting products, because these were small items that could create a lot of added value. Yeah? But today you see a lot of machines and relatively rare, well-developed applications. Now, at Materialise, we have concentrated all the time on trying to build applications. And there, I absolutely agree with Hans that while 3D printing may seem evident today to create any shape, any product, any material, it's always the result of years and years, and mostly a decade at least of work before you end up with a real value application that contributes to people's lives. And we have done so from an early stage. Materialise has grown very rapidly into a global company because we experienced with our first machine that we had difficulties in printing any kind of data. There were 3D printers, but hardly any kind of data. So we made immediately from the first days, we started working with the machine software in order to solve our problems. And it happened to be that these were also the problems of Ford and BMW and Baxter Healthcare and so on, Sony in Japan. So after a few years, we were a global company, giving help to the companies that were using the first generations of 3D printers to be able to do something with those 3D printers. And we also developed, as of these very first years, the same connection to the 3D imaging world for patients, medical 3D imaging. Yeah? So some companies say they start now investing in the digital thread. Materialise started investing in the digital thread for medical imaging as of 1990. And we have improved that link year after year, going from just reproducing human anatomy to the manufacturing and the evaluation of very complex implants today. And this really is what we believe our position in this industry. We try to link as economically and as effectively as possible the different applications to the wide variety of 3D printers and 3D printing processes that exist today. And the key for that link is software. Yeah? The key is solving problems that don't describe exactly what you need to manufacture on the machines and transferring this information based on knowledge from both sides, how the data is generated and needed, and how the machines will process and deform during their processing the components in order to be able to alternate the geometry or to build, for instance, support structures in order to print the right products. And that knowledge to make the software we can only generate because we also have a large service activity. Is that service activity both in medical, where we support more than 50,000 individual patients this year with individualized surgical solutions, or in the industrial applications, where today a lot of our turnover is no longer prototyping, but manufacturing. For Materialise overall, 70% of the parts that are coming out of the facility, and we talk about really hundreds and hundred thousands of parts, are manufacturing components, not prototypes. And all of this is based on the combination of 3 core competences that we have been building from our opening reception, where they were first defined, and there are still the core competences today. The 3D printing know-how itself, the engineering required to build good 3D prints, because it's not true that you can print anything anywhere, and the software development that automates this process. So core competences organized around in the middle of a commercial platform with platform technologies to support a lot of customers, industrial, medical, and consumers. It's our take on the 3D printing applications market. And we call our organization, in Jim Collins' terminology, a flywheel around the core of core competences that we have. It's the entire concept of Jim Collins that come back, not only in the way we operate, but also in the way we have structured the company. With that, we have created a software platform for 3D printing that allows to read any kind of data and prepare them for any kind of 3D printing technology according to certain families, and that's not based on the material or the physical process, but on the data type that these machines require. Vector-based, image-based, nozzle-based, and so on. Now that platform is in fact something that needs to collaborate with a lot of other software packages. Yeah? Because a 3D printing activity gets more and more integrated in a total industrial activity. And in the medical sector, that can be extreme, ranging from connections to the radiology department, the surgical departments that need to provide input for the manufacturing of a single component, up to the integration of a metal sintering machine in combination with a few finishing machines on a standard shop floor. All of this requires a lot of different software systems, and for the 3D printing operations as such, Materialise has 25 years of experience in trying to make this process flow work and connect all the pieces in a way that it is an independent backbone. Now this system leads to the creation of added value. And that's where our employees and myself are so proud about. It's often about real innovations in the framework of our MGX collections. We created the first generation of consumer products by famous designers. Today, this work is still ongoing. Yeah? Like, this is a collaboration between Nicolo Casas and Anouk Wipprecht as designers with Intel and Materialise in order to create an interactive dress that becomes more and more wearable as the different versions are being developed. Yeah? It's really cutting-edge applications of different technologies together. However, we are as proud, or even more proud, about those simple insoles. And simple insoles is the result of the fact that we started looking at orthopedic applications at Materialise in the 1990s, and that during the years 2000 we were involved in multiple research projects that resulted this year in the establishment of a daughter company of Materialise together with the company RScan that takes foot impressions, not necessarily optical scans, but dynamic foot impressions of your feet during walking or running, and that takes that information and based on scientific evidence converts them in a dynamic support of your foot sole during walking. Thanks to this technology, Paula Radcliffe, who really had to give up her career because of injuries and because of the wear she got from all the running she did as a British athlete in all the marathons and other long distance contests she was competing in. She had to abandon running because of the wear. Thanks to a better equilibration of her body with those insoles and of course also a corrective surgery, she has started to run again and wants to compete again in 2015 in the London Marathon. Yeah? This is just one example, but in fact those insoles can really make for thousands and millions of people that they will walk a little bit better, that they can have better sports performance with less pain, but also that their joints can be saved for a longer period of time. And it's bringing a totally new scientific approach through the world of podiologists. Because in the end, podiologists have been looking at people, and based on their experience, they then talk to an orthopedic technician. And this orthopedic technician then, by his experience, crafted something, but without any feedback loops, without any control of what is improving by that hand-produced insole. Yeah, there were some large group of people studies that said, yeah, if we consider 1,000 people, there is a minor improvement on those people. Yeah? Now, this technology is tested in a totally different way. For instance, we have a scientific article out with the Additive technology that was tested on the British Special Forces. As you know, those guys have a very tough training program, and only a very small percentage of them makes it. Yeah? Based on their foot scans, they were distributed in 3 groups. One group of people who had very good feet, and it was clear that from this group, approximately 30% survived the training. Then you had the people with minor foot problems. From this group, approximately 10% survived the training. And then you had the group with the bad feet, and from this group, only 1 to 2% survived the training. After giving this kind of insoles, there was a total change. For the second group, the survival rate became also 30% of 6 months of training, and for the third group, it was not yet 30%, but it became 10%. So the increase was even bigger, but still quite a few people failed. Yeah? On an individual basis, that is now tested in order to improve in very severe circumstances how much those little insoles can contribute to better walking conditions. We are also very proud that our software backbone is present in all the hearing aids that are being printed by a company like Phonak. It's an application where 3D printing has brought enormous change in one industry and has created much cheaper solutions, much more cost-effective, that are much more functional due to much less pain for the patients. And that's done by Phonak alone for more than 1 million patients a year. And recently we announced that we, after investments that started in 2008, in which a group of 65 Materialise collaborators was heavily involved, that we have been able to start making guides based on X-rays rather than on CT or MRI scan. This is an important evolution because still 80% of the people on a worldwide basis that receive a knee implant don't go through a 3D scan like a CT or an MRI. And with the possibility to base the guides directly on the X-ray scans, it becomes accessible for 100% of the people, but it becomes also possible for the orthopedic industry to reduce their costs a lot, because it's well known that guides have the potential to reduce the amount of surgical kits that are needed in a surgical theater from 7 to 10 to 1 or 2 for a single procedure. This is an enormous cost saving for the medical device industry. So with this example that I think is one of the newest values that Materialise is trying to bring to the field of orthopedics, in this case, I want to close my presentation, and I want to hope that you appreciate the work that is being done by the 1,000 people that work at Materialise and are constantly giving the best they can to create products for this better and healthier world with 3D printing. Thank you very much.